We need to evaluate this integral where C is the circle, mod z minus iota equal to 2. So 2 is the radius and iota, that is the center. So when drawing this circle, we have the center at iota. This is minus iota, this is minus 2 iota, this is iota. Centered at iota, this is 2 iota. Now when putting this denominator equal to 0, we are getting the point z equal to plus minus 2 iota. Which of these 2 points lies inside the circle? Only 2 iota lies inside the circle and negative 2 iota lies outside the circle. So only 2 iota lies inside the circle. So we are going to apply the Cauchy's integral formula only for this point. Now what could be our fz? How can I write this integrand? It is 1 divided by z plus 2 iota into z minus 2 iota whole square, right? What is fz here? Because when taking the denominator equal to 0, for which factor we are getting z equal to minus 2 iota? For this factor, right? So the factor for which we are getting the point outside the circle, take that factor along with the numerator as your fz. So fz is 1 divided by z plus 2 iota whole square, right? जिस फैक्टर के लिए पॉइंट सर्कल के बाहर लाई करेगा, उसी फैक्टर को आपको fz में इंक्लूड करना है न्यूमरेटर के साथ. एंड सेकेंडली, this integrand is analytic everywhere except the point z equal to plus minus 2 iota. Because at these 2 points the denominator is 0, so integrand is not defined at these 2 points. So this integrand is analytic everywhere except z equal to 2 iota and z equal to negative 2 iota. So we have to apply the Cauchy's integral formula only for this point, z equal to 2 iota, right? Point which is inside the circle. So clearly the integrand 1 divided by z square plus 4 whole square. This is analytic everywhere except z equal to plus minus 2 iota. Analytic means it is differentiable everywhere except at these 2 points. But z equal to minus 2 iota lies outside the circle and z equal to 2 iota lies inside the circle. And we have taken our fz to be 1 divided by z plus 2 iota whole square, right? And because of the square over here, we also need the first derivative of fz for applying the Cauchy's integral formula, right? Okay, let's take the derivative for this. So it is minus 2 z plus 2 iota the power minus 3. It can also be written as z plus 2 iota the power minus 2. Because the point 2 iota lies inside the circle, we also need its first derivative at z equal to 2 iota. So at z equal to 2 iota, what is the derivative? Just put z equal to 2 iota over here. We get minus 2 into 4 iota the power minus 3. So that is equal to minus 2 divided by 4 iota the power 3. So that is minus 2 divided by 64 iota cube. That is equal to minus 2 divided by 64. Iota square is negative 1. So I am having iota over here with negative sign. Cancelling this. So we have 1 divided by 32 iota. Now since fz is analytic inside and on this circle and the point z equal to 2 iota is inside C, so by Cauchy's integral formula we have the given integral to be equal to, because we have taken fz to be equal to 1 divided by z plus 2 iota whole square. So I am writing here, okay, let me write that first. How to write this? It is z plus 2 iota whole square and z minus 2 iota whole square, right? Because we have taken our fz to be this. So I am writing here fz divided by z minus 2 iota whole square. Is it okay? Fine. dz. Now by Cauchy's integral formula, this is equal to 2 pi iota into, I'm having 2 over here, subtract 1, we get 1. So write here first derivative. Whatever number you are getting here by subtracting 1, take the derivative accordingly, but at z0. Z0 is the point lying inside the circle. Divided by whatever be the derivative, write the factorial for that. So this is 2 pi iota into f dash. Which point lies inside the circle? 2 iota. So writing here 2 iota. So this is 2 pi iota into, what is the value for this? 1 divided by 32 iota. So 1 divided by 32 iota, iota cancelled out, cancelling also this. So we are getting pi divided by 16 to be the required answer for this given integral. Okay, thank you.